Okay, I think we're back. Are we back? That was weird. I don't know if that was on my side or on some other side. That was interesting. Okay, so where were we? We were discussing kind of the trends in education, and we're trying to defend this idea of, can we abstract away a lot of this prior knowledge? And so what do we mean by this prior knowledge? Let's take some concrete examples of things that most computer engineers will learn. So let's go back to one of the early courses in logic design. So what do you learn in logic design? You learn about gates. You learn about Boolean algebra. You'll typically learn about something like, what's another thing you'll learn in here? You'll learn about reducing logical expressions, so Boolean algebra equations. And this will be through things like Kmaps, Quine-McCluskey. That's not quantum mechanics, it's Quine-McCluskey. So don't worry, I'm not saying you need to know quantum mechanics in order to do a logic design class. But we have these. What else? So let's just move on to another class. So I think that's good enough. And then I guess also state machines. We also learn state machines. So what's another common class? Some microcomputer systems. And what do you learn in here? You generally learn about, programmers modeled for some embedded system, and then you actually, program some microcontroller. And the kind of stuff you do with this microcontroller is typically, you'll blink an LED. Maybe interface with some peripheral. Let's just say interface with the I/O. Okay, and so my main criticisms come from actually this layer. So let's talk about some key points within this general realm that are interesting to note. So gates shouldn't take that long. We're talking about what a gate does. You could get over every single logical gate in half a lecture at most. It shouldn't take that long. Boolean algebra, it's an interesting subject, but in regards to computer engineering, there's a lot of things that it doesn't make sense to keep including in here. And that's mainly what a huge portion of logic designs classes typically be, which is this learning ways in order to reduce these logical equations to create more efficient circuits. And so the problem is, this is done by software. Lev, thanks for the 15 bits. I appreciate it. That was a mighty big symbol that came up on the screen. So the biggest problem right now is that a lot of that's done by software now. So, when you start doing a design and you start needing to go, okay, here's my state machine, that's just going to be automatically reduced to its minimum amount of gate form for you. You don't have to do that by hand anymore. You're here for the weak stem takes? Well, good. That's all you're going to get today. Unless you were here earlier. Earlier we talked about micro benchmarking and how to write CUDA applications. That was fun. Okay. So, in a classic logic design, half of what you've done, or more than half of what you've done after the logic design class, or maybe even more, Karnaugh maps are great. You gotta hate. Why you gotta hate on handy tools? Because they're not handy. When are they handy? Whenever in a real world scenario will you ever use a Karnaugh map? The answer is never, and if you do, you should be fired. Because there's logical solvers that can do all of that work in 2 seconds. Not 2 seconds, milliseconds, microseconds. There's no point to learning it. The only reason why you should ever need to learn a lot of this stuff, besides, hey, this existed and this was great before we had computers to solve this, other than a historical perspective. So what is the Kmap? So a Kmap, let's make a new page. A Kmap is a way for solving these Boolean algebra equations. And it's a way to do it visually, and so it's really only meant for someone that is trying to solve this visually. So let's look at page after, and let's do a quick example of a Kmap. So what's a Kmap? So if we have an equation, so let's see. So a Kmap for a 4-variable equation. So let's say we have, let's do 3 variables. Okay, we'll do 4. So if we have 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, let's do 3 variable. I don't feel like writing out that many. Okay. So let's do a 3-variable Kmap. So then we only have 8 different things. So let's say we have a circuit with 3 inputs. So these are all the possible inputs for our circuit, and we'll call this A, B, and C. And let's say on the output, say D, we want this pattern of maybe 0, 1, 1, 1, 0, 0, 0, 1. Okay. So we want this pattern on the output for each of these inputs. So if we get all zeros, we should get a 0. If C is 1, we should get a 1. And so we could put this in terms of we could write these out in terms of equations, but we could just as easily map it out with a Kmap. So in this case, we'll have 8 boxes, and this side will represent A, and this side will represent BC. And so this will be 0, 1, and this will be 0, this will be 0, 0, 0, 1, 1, 0, 1, 1. And these are combinations of B and C. So what we'll do is we'll map these out to exactly where they go. So if A is 0 and BC are 0, this should be a 0. If A is 0, B is 0, and C is 1, so that's this case, A is 0, B is 0, C is 1. We want a 1 here. If B is 1 now, and all the others are 0, so that's this case, it should also be a 1. And then if B and C are both 1 and A and 0, it should be a 1. Now, we'll write these in. So this will be 0. This will be... Oh, sorry. I flipped this. This should be 1, 1, 1, 0. Okay. And then... I don't think that changed anything here. Yeah. These are all 1 still. So the way this should change should be this is a 1, this is a 0, and this is 0. And I basically just mapped these patterns onto this table. Now, what a Kmap is, it's a visual way of doing this reduction. So what you can do is you can group things in powers of 2. So I can say group these together. I can group these together. It has to be a power of 2, so I can either group 1 thing, 2 things, 4 things, 8 things, and then I can group these 2 together. And basically what happens here is I can use these patterns and I can see what's changing between them to write a reduced form logical expression. So for something like here, the bits that are changing, those are the ones that I ignore. So A changes from 0 to 1 here, meaning that A doesn't affect the input here. Whether A is 0 or A is 1, it doesn't matter. This is going to be 1s regardless. So here I would just write BC. Now if I look at this circle right here, I would look, okay, A is a constant and it has to be 1 or it has to be 0 here. So this would be B prime, or sorry, A prime. And then I look between these two. B goes from 0 to 1, so it changes. But C is a constant here at 1, so it's going to be C. Or, if I look here at these two, it's the opposite. It'll be A prime. This time, B is both 1 here, so it'll be B. So it's a way of writing this kind of reduced form logical expression without having to write out all of these terms. Instead of having to write, say, A prime, B prime, C, or A prime, B, C, prime, or A prime, B, C, dot, 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 and fill in all the ones where it's 1 here. Instead of having to do that, I can just do this handy-dandy graphical way, and it solves it. Now, what's the problem with this? The problem with this is that it's pointless. You can plug this into a computer, and it will solve it for you. Now, there's always this argument that's, okay, well, what about if computers fail? Or what about... There's always this dumb argument, and it's like, if computers fail, we've got a lot bigger problems. I too don't learn how to do long division because computers do it. Yeah, sure. I know that's being sarcastic, but that's a completely different point. Yeah, no problem. That's a completely different point. And the point is, there's a certain point where the thing is, that's extensible. Dividing two-digit numbers is the same thing as dividing, you know, 20-digit numbers. They're exactly the same. This is not extensible to anything. This is a one-off example. This is a one-off thing that's only used as visual. So it's pointless. It's pointless to teach it because it's not extensible. It's a visual way for solving something. And there's so many of these visual ways for solving things that we don't use anymore. I don't think people, for control systems, people certainly don't hand draw out root locus. Visual tools are useful. Why do you say they're pointless? Visual tools are useful if you need to use them. You don't need to use a Kmap anymore. Having a mental model is important. No, not all the time. Having a mental model is important I would argue that most people doing digital design aren't going through their head and going, okay, well, how is the computer going to take my expression and turn it into gates? And so the answer to that is they're not. Designs are so complicated now. Nobody's doing that. We're at the age of we're still trying to get behavioral synthesis. We're not working at this level of how is the computer taking my truth table and how is it visually turning into gates? That would waste so much time during design. So why are we still learning it? If we really want to learn this, here's the hot take. Okay, you can still learn Boolean algebra. It's important that you at least understand how things get reduced. Kmaps are a pointless tool. Kmaps were only important when we didn't have computers to automatically do this for us. What do Kmaps do? They do the exact same thing that Boolean algebra laws do. They reduce equations. So why are we learning a visual example of how to reduce equations when we've already learned the mathematical way? It doesn't make sense. If anything, we should learn what algorithms a computer does to reduce these equations. It's certainly not doing Kmaps. Kmaps are not the most efficient way. It's just the most visual way for someone to do it by hand. So that's hot take number one. And that's especially dealing with Kmaps. Visual ways don't make sense, especially if they're visual ways that aren't done at the underlying level. It doesn't make sense to do it anymore. The second thing is this common microcontroller thing of blinking an LED. And you waste so much time learning how to blink an LED. It doesn't make sense. So let's move on to point number 2. What am I going to draw? I'm going to draw in black again. So point number 2 is, let's call this the blinking an LED problem. What's the right Hello World project for a microcontroller? My point is that there really is no right Hello World project for a microcontroller. It's that a lot of this is just pointless anyway. Like this idea of having everybody like get a microcontroller and do something simple like this. You're never going to go into a job in industry and go, hey, let's talk about this. There's better ways to allocate time doing this. And it's not by having everyone every semester blink an LED. There's levels of abstraction because a lot of times this includes things down to the level of, I've seen some universities have it where it's, okay, blink it using assembly, then blink it using C that gets compiled down to assembly, and then use the timer built into the microcontroller to do the delay. Then use PWM, which is pulse width modulation. So use PWM to fade an LED. And then, you'll have some other things in here, which is breadboards are the leading cause of HIV contractions in academia. So the problem with this is that it's so far removed from anything that you would ever do in the real world. Are we just going to teach people how to blink LEDs as the first thing in a microcontroller course forever? It doesn't make sense. There has to be a better way. Now, I'm not saying that I have the answer for the better way, but I'm saying this idea of teaching people how to blink LEDs, why do you teach Hello World when you code? Well, Well, this is different, isn't it? If you assume some level of programming, then blinking an LED is the same level of complexity. This is, you don't take a microcontroller course without having taken a computer science course before. I'm 99% positive that a computer science course is a prerequisite for this. Now, the problem is the granularity at which this stuff is being taught. So my problem with this is not that... My problem with this is that it's not scalable. How are you going to tell someone, here, you have an entire course where, what have you learned in the course? If someone doesn't know how to blink an LED, what makes you think they can do more advanced stuff? Okay, here's my here's my counter to that. Just because they blink an LED doesn't mean they can do anything else. It's so far removed from any meaningful work, blinking an LED. No, this is actually Why So Green. This is Why So Green. It's not a meme. This is actually Why So Green. Look, and here's my proof. I wrote it at the top in honor of Why So Green, because he's dead now. So my point is, there's a lot of problems related to this, and that's that it's so far removed from what you'd actually do in any real-world scenario. And I'm not saying that, like I said, I'm not saying that I have the better way to do this. But I know almost certainly that this is not a good way to do this. There has to be a better way than blinking an LED, or having a class where so much of it is about blinking an LED and learning this low-level stuff. And, you know, there is blinking an LED or something. Maybe my point should be that should take up a class, like a single class. But there's so much knowledge to be built on top of that it's insane. Like when you graduate with a computer engineering degree, I think you're thinking about a straw man rather than most curricula do. I mean, it's possible, but I don't think that's true. I think a lot of these older courses, the Kmap stuff, but like you're talking about basically not teaching the equivalent of Hello World, introductory context, new way of developing people aren't familiar with. Sure, I get what you're saying. I'm saying that too much time is focused on this specific application, on this specific microcontroller. I feel like it's kind of like with an operating systems course. Like operating systems courses, 90% of the time they will always use an academic OS. They will always use something like is it Xeno? Is the one that was made by like Berkeley or MIT? They'll always use this academic operating systems for teaching. And the problem with that is that you get the operating system concepts down, but it's so far removed what's done in a real operating system. So, you know, besides this like ranting about... So, besides just ranting about what is more or less pointless, and the fact that there's such a big disparity between what you do in a degree and then what you do in the real world, I guess the bigger question is, how do you bring how do you bring education towards industry? That's the bigger question. Sure, you can learn things without how they're actually done in the real world, but you get The Linux kernel is so far removed from some baby kernel like Xenu that it's they're incomparable. So the problem that I seem to have is, and I don't know the solution to it, is that how do you... There has to be a better way to abstract certain parts of the real world and bring them into academia. Because an academic OS... So I never said they should be able to dive right into reading kernel code. The problem is that most programs will never dive into actual Linux kernel code. The problem is that most graduate courses in operating systems will still be using an academic operating system. They won't be like digging into like the Linux kernel. So this isn't just with undergrad, this is with grad too. So in intro grad class in operating systems, it's very likely that they'll be using like sometimes you want a test bed for new ideas. You won't get that with Xenu. You can't test something you can't test... It's so far removed that what does a test bed for new idea even mean at that context? If you're doing a new process scheduler for something that's a single core or some super simple operating system, then it's not simulating the real world, so there's no way to tell if it's a good idea or not. You have to compare apples to apples, not apples to oranges or whatever. So it's not for testing, it's not a test bed for new ideas in that case. It's just a bad comparison. When you try out a new design, do you model everything under the sun, or do you restrict what you experiment with? Yes, but you restrict what you experiment with in a realistic setting. In a GPU architecture simulator and GPU sim, you don't simulate the entire CPU and how it communicates with the GPU. You just instrument the instructions, or you just do all the CUDA API calls to the GPU and you simulate the instructions. But you don't simulate the entire CPU. You have to restrict what you experiment with, but you have to restrict it realistically. And so the problem is, so this is the main problem. It's how do you bring education closer to industry, because the current methodology doesn't make sense. Tech is just getting more and more and more and more. So when you make a car, do you try to bolt it on top of an old one right away? Or do you maybe prototype new designs? So once again, you can't prototype a new design on Xenu. You can't prototype a new design on something that is so far removed what happens in the real world, you can't get any accurate results from it. That would be like, okay, well, let's prototype something for a Fermi or Kepler architecture GPU, even though we're on Volta. It doesn't really make sense. The problem is you have to... Yeah, a lot of schools do try to push this with internships, but I think they're doing a disservice. I feel like they're just kind of pushing off their job to industry. Now, of course, you could make the argument that academia is purely for academics and it shouldn't be focused on industry. But I mean, that's not the case, really, right? You have to get a degree to get a job, especially in like something like engineering. You're never going to get hired in an engineering place for the most part without a. You're never going to get hired in an engineering place without a degree. There's like the one-off example, of course, but that's just the case. So there's the problem. It's how do you bring education closer to industry? Because you can't make the argument that education is supposed to be above industry and focus purely on the theoretical and the academic, because it's necessary. It's necessary for industry, and everybody knows it. So how do you make it more realistic? And it's an interesting question. And I don't know if I have the answer. But there has to be a way for an operating system course there's certain things, and I would guess I'm not. I don't do operating systems research, but I would guess that you can abstract away most of the Linux kernel. You don't have to understand the entire Linux kernel to work on the Linux kernel. If you isolate the hooks that you need to latch onto to say make a new process scheduler, then you never need to know about. So making a toy operating system is going to teach you more about operating systems than writing a kernel patch. So from the people that I've talked to, which includes professors in the operating systems area, listen, if you're able to pull up an example of what came out of the XENU academic operating system, as far as relevant, kernel ideas or research that led to anything meaningful out of XENU, I'd be happy to change my mind. But it doesn't happen. When people do operating systems research, they don't do operating systems research on XENU. That's purely for teaching. Most people consider, why do you have to pick one straw man? I'm saying on the aggregate. Haskell is a toy project that led to incredible meaningful growth in the field of programming languages. I can't compare against Haskell because I'm not a computer scientist. However, I can't think of something that was done in an academic operating system that led to real world things. That's my problem, is that there's a disconnect. Is that academic operating systems is great for teaching introductory theory on operating systems. I just got done reading a paper about authenticated data structures that would have been feasible to implement directly in a compiler, so they made a toy language to implement the idea and then brought it into the real world. Listen, you're getting pretty mad. I'm not saying that it hasn't happened. I'm saying that academia is getting pretty darn far away from happens in the real world. If you don't get that, then, if you just disagree with that, okay. I'm not going to convince you. But my point is that we're getting pretty darn far away from what happens in industry in the real world with what happens in academia, or at least at the undergrad level. Now, maybe you don't like the examples that I did, but if you don't agree with that, then, I think you're wrong. I feel like if you're going to do meaningful work on, say, a real-world kernel, you would have a better time hacking around in the Linux kernel than what most operating system knowledge you would get from the dinosaur book on operating systems or operating system principles and practices. Because that stuff is so old. No one does stuff like that anymore. Like, the modern stuff is so far what's in these textbooks. That's the problem. That's my point. It's that I don't have a solution to it, but it's the problem that I wish I had the solution to. It's how do you abstract away so much of this stuff that's so outdated? Like, I understand the need to go through in a computer organization design course or a intro computer engineering course. I understand the need to go through, or why people think that there's a need to go through, I don't know, a single cycle processor, then a multi-cycle processor, and then a pipeline processor. But my question is, are we really going to talk about single cycle and multi-cycle processors before getting to pipeline processors forever? like when does it become a point where those are so irrelevant? Like maybe we've moved past that point and we're way in the future now, and we have some crazy data flow architectures. Are we still going to be going over single cycle, multi-cycle, pipelined data flow forever? I don't know. I don't feel like uni is about teaching students the current cutting edge technology, but rather teaching how to think and how to solve problems. Yeah, so I agree with you to some extent, but my point is that should the university system be doing more? Should the university system be doing more than just, yeah, because if you think about like the ability to solve problems, well, the problems that we want to solve are probably the problems that industry wants to solve as well, right? So academia wants to make faster processors. Do you know who else wants to make faster processors? Intel, Nvidia, AMD. There's common problems between these two. Now, Intel wants to make faster x86 processors. Nvidia wants to make faster GPUs. But the core idea is the same, right? But it's, it's things get hard, right? Things are getting a lot harder. So take transistor scaling. So we can't scale transistors much further. I think at the minimum theorized, it would be hard to do more with the amount of pointless. So I'm tilted because you're effectively saying let's not teach fundamental things because they're not state-of-the-art advanced PhD level work. It's not what I'm saying at all. What I'm saying is that it doesn't have to be state-of-the-art level PhD work. What I'm saying is that there's probably a better way so you don't have to relearn everything that's been done in the history of computer engineering to graduate with a computer engineering degree. Do you think we're going to switch away from silicon to something more efficient or something else? Listen, I'm not a devices guy, so I won't speculate on that. I can't speculate, really. I just don't know enough about the subject area. There's got to be something revolutionary that happens because at the minimum theorized level of transistors, the channel width is 12 silicon atoms. That's the channel length is 12 silicon atoms. That's at the pretty much minimum theoretical. Maybe we could get there. Maybe we could get their level of transistor size, which is like, was it 3 nanometers? We're not going to get to 3 nanometers. We're having the trouble getting to 10, and we want to go 1/3 the level. I think new AMD is 11. Maybe, I don't know. I know that I think Volta was 12. Volta back in 2011 on the roadmap said that by Volta they wanted to be at there's 7 nanometer process now, not in production. There's 7 nanometer, but not in production. The point is production. So you can have 7 nanometer, but it doesn't mean that you can just pump out chips at 7 nanometer because you'll probably have awful yield. Tin silica. So the problem is with 21 billion transistor chips. High volume production, first 7 nanometer FinFET technology. But what's the size of these things? How big are these chips? It's not saying the size of these chips. Let's see. Our N7 plus silicon, we've demonstrated equivalent or better than yield on both 256 megabyte SRAM then compared to the N7 baseline. Yeah, how big are these things? So I don't know how big these chips are. I mean, like I said, 7 nanometer exists. I mean, it has existed for, you know, a good bit now, I think. But that's not the problem. The problem is getting x86 to 7 nanometer. And they're having a trouble getting to 10. And it's how is NVIDIA with their 21 billion transistor Volta chips going to get to 10 and then 7? So yeah, there's a 7 nanometer process now, but it's a matter of something being in production for things that people are buying. So like processors like that, because that's where the big money is. The big money is, you know, NVIDIA wants to get to 7, or they want to get to 10 first, and then they want to get to 7. But whether or not we're going to switch from silicon, I mean, I don't know. I have know nothing about the future of computing in that regard. That's such a wide out there area. There's so many. Well, so here's the thing. There's a lot of really cool ideas coming back to the forefront because we've relied on Moore's law for a lot of time. So a lot of ideas got kind of buried because we have to move off silicon if we want to keep Moore's law probably. Yeah, but there's probably a better way than to move off silicon. So the better way is probably move away from x86. The better way is to do a completely different architecture. Because the reason why we're getting bottlenecked now is because we've optimized for one specific design for all these years. We've optimized for x86. So Tripp's are quantum computers part of computer architecture? That's mainly physics, honestly. That's at such a theoretical level that you basically just have to be doing physics. All the people that I know at my university that do quantum stuff, they're all in the devices area, and they're all basically physicists. So I would say that's not really computer engineering. That's a lot, because you have to focus on getting quantum computing to work first. So you have to get it to work before you can start theorizing the architecture for a quantum computer. And I'll have no idea about that, so I'm not even going to step into that lane. Yeah, that's something that I do not feel comfortable talking about because it's just so far away from any modern architecture now, because it's in this glorious kind of era of it's the frontier that no one knows anything about, really. By no one knows anything about, as in there is no quantum computer yet, so there is no baseline to start going, this is how you build a quantum computer. Because it's so hard to make one that isn't at a couple degrees above absolute zero. Isn't the problem with quantum computing now that it has to be super cold in order for it to be stable or something? I don't know. It's not my area. Okay. Okay. So if the question is, are quantum computer, or if the question would be, are quantum computers going to be part of computer architecture eventually? Not for many years now. It looks like it exists, but very early. Yeah, I mean I think the point is, I just heard something recently that they were able to do addition with quantum computers. That was maybe a couple of years ago or something, but that's that's the rough level that they're at. Is that they're doing basic numerical operations now. Now, will it be the future? It's not going to replace computers as we know it. There's a talk by Doug Berger, who's a distinguished Microsoft computer architect. And he has a talk on it, and he says that quantum computers won't solve all of our computing problems. They will solve problems that quantum computing will be designed to solve. Quantum computers work, but they have problems with thermal noise. Maybe. Like I said, I know nothing about quantum computers. Okay. All right. Hot take number 2. And that's that engineering degrees need to change. Now, are you CS or CE? I was a double E in undergrad, and I'm a computer engineer now. So, what do I mean by engineering degrees need to change? So, the hot take here is that I don't think that the current... This always gets really hard because once you start getting into the depth versus breadth argument, it gets tricky. Because what courses do you cut? What courses do you leave in? So, as an electrical engineer, you take a lot of courses. In most engineering degrees, you take a lot of courses. And you'll take a course on control theory. And you'll take so when I was an electrical engineer, so let's look at what I took as an electrical engineer that was required. So I took a control systems course. Let's just pick out a couple examples. A control systems, a signals course, a discrete signals course. I'm just picking out the ones that I don't think I've really used anything from since I've taken them. So control systems, signals, discrete signals, I'd cut 69 credits of hard technical study and replace with ethics/management courses. I think that's probably a decent idea. Those are all pretty low-level concepts, right? Doesn't get used often. Well, I mean, none of the stuff that you learn in these courses well, it depends what you mean by used often. I mean, as far as used in the real world, none of this stuff gets used. Things that are built on these ideas get used in the real world, but none of these things get used. No one's hand doing root locus diagrams to find stability for control systems now. A lot of control systems now are created using machine learning. So you just feed some ML algorithm, your inputs and your outputs, and you do some training and you get your controller. So a lot of this stuff, it's the theory that is used in the real world are they're built on these things, of course, but this low-level stuff doesn't really get used. But these are all things that are generally required by a double E degree at most universities, I think. So a control systems course, entry level. A signals and systems course, entry level. I had to take a discrete signals class. That was mandatory for me and mine. What other class was, I don't want to say a problem, but was pointless to what I do now, not a pointless class. Let's just focus on these three. So here we have, no, that wasn't mandatory. So here we have 9 credits of, we can say rigorous technical work. I feel that way about a lot of CS courses. I don't think Turing machines get built often in real life either. But learning about Turing machines is important. All those skills can help you prove meaningful properties about your system. Yeah, it's hard for me with computer science because a lot of times people conflate computer science with programming, and I'm under the impression from most people that I've spoken with that that's a really dangerous thing to get mixed up. That graduating with a computer science degree doesn't make you a programmer, just like being a programmer doesn't make you a computer scientist. So I'm not even going to step into that field. I'm a computer engineer. It's different. CS is part of mathematics. I would guess that. Just look at someone like Donald Knuth, right? Donald Knuth is a mathematician pretty much, and he's one of the fathers of computer science, or one of the biggest people, with all the sorting algorithms and stuff. I've never heard of strict programming classes part of my curriculum, mostly math and theory. Yeah, sure. Although a lot of CS places, they do have tracks now for like database stuff, right? And they have stuff for like cloud computing, and that's more application focused. A lot of CS departments have that now. Okay, but here's my key point. So there's a lot of classes like this typically in a that'd be informatics. Maybe it's not that everywhere, and a lot of places that's within computer science. I don't have the numbers on how many universities put it there or here, but in the 2 or 3 universities I'm familiar with, it's all in the computer science department. It's just a different track at the computer science department. But like I said, I'm not going to steer too much into that lane because I don't have a computer science degree. Okay, so here's a gripe I have about engineering degrees, is that, and I don't know how to get around it either, and it's the fact that you have to take something like control systems, something like signals, something like discrete signals, and most CS departments are pretty mixed between academic and software development. I think most are, yeah. I mean, that from my experience of the ones I've looked at, it feels like all the practical stuff and the theoretical stuff are in the same department under different tracks that you can go down. So here's my gripe, and it's that so let's take example 1. You're a freshman and you know exactly what you want to do. And let's say this stays true. Let's say this stays true your entire degree. You get in there and you say, I want to be a computer engineer. I want to do computer architecture. Well, you still have to take the control systems class. You still have to take the signals class. You still have to take the discrete signals class. That doesn't seem like a great idea. It seems like you're wasting a lot of time and energy to something that won't help you. Now, you can always... So that's for the first example of someone that knows exactly what they want to do, and it makes sense for them to not take these classes. Let's take scenario 2. We have a freshman. This is really only relevant to if you're a freshman or you're coming in without much experience. So you're a freshman and you swap concentrations. Say you get a little bit into your degree and you decide, I really don't like this. And that was the case with me. So I started out as a mechanical engineer, and then I decided I don't like mechanical engineering. And then I switched and I became an electrical engineer, and I focused in control systems. And I got through some tech electives in control systems, and then I decided, wow, I'm not the biggest fan of control systems. And so I switched and I became a computer engineer, it was an electrical engineer with a focus in computer engineering. So I took computer engineering tech electives. So the problem I have here is that once you figure out the lane you want to be in, you realize that you've wasted a ton of time learning these other fields. Now, you could make the breadth argument that you have some holistic knowledge of uh, of your entire discipline, right? You could make some argument for that case, but I guess the question is, do most people care about this? Is anyone going to say, well, I have this holistic knowledge about electrical engineering because I took a signals class and a discrete signals class and maybe an electromechanical systems class? And so it feels like there's a problem here. It feels like if you know exactly what you want to do, and this is likely not the case for most people. Most people figure out what they want to do after taking some classes. But once you figure out what you want to do, you realize that you waste a fair amount of time taking classes that you don't care about. Like, I remember from my undergrad, there's 4 or 5 classes that I wish I never took, and I haven't used since I took the final for that class. And make the argument. You can make the argument that well, you got some more holistic knowledge on the subject. But that doesn't seem like a positive. That doesn't the positive that you get out of that, it doesn't seem like it's that great. Like, what are you gonna like? This isn't saying that everything you have to learn has to be practical or applicable to your degree, but it seems like we waste some time in the degree. And that our degree isn't set up to be flexible enough. So what I always thought would be a better idea. So here's the idea that I toyed around with and that I thought would be interesting, and that you would have a general studies degree, or whatever they call it, a general education degree that isn't a joke. Forcing people to take psych when they're in STEM. Hey, I mean, that might not be a bad idea, or at least some applicable. So the biggest point I've had is, what if you had a general education degree that wasn't a joke? I feel like most people, when they think about someone that got a degree in like general education or something, or not like an education degree, but like or what is it called? Is it general studies? Yeah, general studies. So it seems like most people, or a lot of people, would be better off with a general studies degree in engineering. What would you do with that degree? What's a general studies degree? So there's typically an undergrad degree that's general studies, and basically the requirement, so today, the requirement is you take X electives from 3 different majors. It's something generally like that. You've never heard of anyone getting that? I mean, if you're in a degree, if you're in engineering or you're in math, you're typically only around people that are getting math degrees or STEM degrees. Or if you're in psychology, maybe you're only around people getting psychology degrees. But this is a legitimate degree. And it's generally considered a joke. Because, now I'm not going to pass judgment and say it's a joke. I actually like the idea of a general studies degree. My entire family is academia pretty much, and I've never heard of it, or is in academia and I've never heard of it. So most people have never heard of it because you don't typically interact with the people that do it. It's generally for people that don't know what they want to do, and sometimes people knock it as being the easy way out for a degree because you don't have to dig into like the end level of any degree path. You can basically survey a bunch of different degrees. Let's see if we can. Let's look it up real quick. Is it gonna? There it is. General Studies degree. Bachelor of General Studies. It's an undergraduate degree offered by many colleges and universities in the Western world. It offers students the ability to design a unique degree plan meeting their academic institution's general requirements. This flexibility allows students to complete a bachelor's degree that offers an element of individualism absent from other degrees specific to a particular discipline. So it's generally a liberal arts degree, but we haven't gotten to my implementation yet. So I think that you could have a general studies degree in engineering. And so most places have a first-year engineering program. Most places you start out as a general engineer. You don't get accepted into the College of Electrical Engineering. You get accepted into the College of Engineering. And then you have to qualify to get accepted into the electrical engineering program or the computer engineering program, mechanical engineering, etc. But once you're in that program, they have general chem programs. Oh, maybe. I mean, I'm not sure. So I think that it's a good idea, and that most colleges should have a program like this, because most people have no idea what an electrical engineer does or what a mechanical engineer does. In fact, I just saw a subreddit post today that says, I really like mechanical engineering. This is someone that's coming into like a freshman, and they said, I really like mechanical engineering because I like to build things and get my hands dirty and build things. And then they said, but I also like electrical engineering because I want to be doing soldering and putting stuff together on breadboards. And I had a huge problem with this because that kind of work in electrical engineering is the job of a tech generally, not putting down a tech. I'm not saying that's a bad thing, but that's not the job of an electrical engineer. That's someone that's generally a technician. And then getting your hands dirty and building stuff, that's also not generally the job of a mechanical engineer. Now, mechanical engineers will do maybe some more hands-on stuff, but I mean, if you think you're doing hands-on stuff in like Thermo 1 and Thermo 2 and statics and dynamics and mechanics of materials, you're not doing any hands-on stuff in that class. You're doing a lot of, hey, thanks for the follow, man, I appreciate it. If you think you're doing any hands-on stuff in that class, you're sorely mistaken. You'll have some design classes where you will do hands-on stuff, but if you go into a degree like mechanical engineering and think you're going to be building stuff the entire time, you're going to have a pretty bad wake-up call. So my main point is, nobody knows what engineering is. Or a lot of people have a misconception of what engineers do. Like when I say that I'm a computer engineer, half the people I know think that I'm a programmer. Not true. I can write code, and I do write code often. I'm certainly not just a programmer, though. The other people think I'm an electrician. They hear electrical engineer, and they think I'm an electrician. Lev, you're a computer scientist. You're not a programmer. You can go to a boot camp and become a programmer. There's a difference between a computer science degree. I don't know why you're thinking like just a programmer is an insult to you. You're in a computer science degree. It's completely different. A programmer doesn't take a data structures class. Boot camps don't generally have a data structures portion of it. Yeah, this is a universal problem. You don't know what a subject is about till you actually start doing it. Your parents think that CS is computer repair. Yeah, listen. So the problem with engineering is I'm a computer scientist. I can't program. Well, I mean, there's always the joke that people graduating from computer science degrees can't program their way out of a paper bag. A wet paper bag, that is. There's always that joke, and there's a lot of people that can't. Now, I would argue that that's your own fault if you can't. But I think a lot of computer science degrees, they rely you to teach yourself programming because they're there to teach you computer science theory. Are you not learning everything about Windows in a CS? God, I hope not. Okay, so let's go back to this general studies and engineering degree. Oh, one more thing. So every undergrad that has taken my calc class says, I liked your calculus class, I want to become a math major. And I'm just like, yeah, it's kind of like when somebody does an intro circuits class and they think, I want to be an electrical engineer. Now, it might be a good indicator that you might like electrical engineering, but if you think that electrical engineering is doing some fun projects on breadboards, whew, you got some rude awakenings. Okay, so let's talk about this idea that I had, my hot take of what engineering degrees should be more like, because this is this first example of you know exactly what you want to do and this ends up being what you graduate with. I feel like this is the fringe case. Most people don't know what engineering is, and they certainly don't realize that this is what they want to do all the way through. Also, Arhagius. Hey, thanks for joining us. If you guys haven't said hi to Arhagius yet, he was my first Twitch Prime subscriber. I would go so far to say if you enjoyed an undergrad calc class, you're probably not suited for a math degree. I don't know about that, but maybe. I mean, it's possible. I don't know enough about math degrees. I'm not a mathematician. I've taken a fair bit of math classes, but yeah, I don't know. Okay, so let's talk about this general studies in engineering degree. So what does this allow you to do? So let's look at the pros. You get to survey different engineering degrees. However, what I think is the more important part, there's no penalty for taking broad coursework. So if you're a mechanical engineer and you take statics and dynamics and you take mechanics of materials and then you decide, I took a circuits class, I want to be an electrical engineer, you just had 3 classes that might have become irrelevant. Now, that's a pretty big penalty, and especially with the rising cost of colleges, that's a pretty bad thing to happen. Now, we'll get to the cons in a little bit, but these are the pros for this idea. So you get to survey different engineering degrees, and so you get to really pick what you want to do better. So you get to see maybe what you see a interesting class description in chemical engineering, and you get to maybe take a chemical engineering class. You get to take a mechanical engineering class, an electrical engineering class. So you have the potential for your degree to be a pretty broad one. And this is actually a degree that a lot of universities have. It's called engineering science or engineering management. Now, engineering science is basically, it's a more technical degree, but you get to really do chemical, electrical, mechanical engineering. Engineering management, you generally do maybe those 3 in a lesser degree, and then you tack on a management portion. Now, the pros that I see with this is that you also have the ability to specialize. And you can specialize not only in electrical engineering, but you can specialize in the fields you want to get into. So if you want to get into some field that maybe blends parts of mechanical engineering and chemical engineering, you can do that. If you want to blend together, if you have a job that you know you want to do that blends together electrical engineering and computer science maybe, you can do that. And I think that's important. But no thing is without cons. And so what are the cons of a degree like this? Can anyone guess the 4 letters that I'm going to write here that will be the biggest con of this degree? It's 4 letters. They're all capital. It's an acronym. Who's gonna guess the right 4 letters? And if you're an engineering student, when you're looking at degrees, this should be one of the things that maybe are kind of at the forefront of your mind. It's 4 letters, and it's an acronym. Let's write it in red too. Let's get a little bolder. ABET. That's what kills this degree. That's what kills this degree idea. ABET. Cash rules everything around me, Cream. It's ABET. ABET kills this degree idea. ABET has standards for what you graduate with in order to accredit your program for a certain degree. And the thing is, I don't think you could have a degree that could be this focused or this broad. What is ABET? So if you're not in the United States, I don't think it matters. But in the United States, degrees have to get accredited. And it's basically, there's a minimum standard that a degree has to meet before it gets accredited. I don't even remember what ABET stands for. ABET. It's for engineering, though. What does it stand for? Here we go. It's the accreditation board for engineering and technology, and it occurs mainly in the U.S., like it says, but it is in other countries as well. But it's a primarily U.S.-based thing, and it's basically a minimum standard for you to be classified as an electrical engineering degree, as a mechanical engineering degree, as an engineering science degree, as an engineering management degree, etc., etc., etc. So the biggest problem with a degree like this is I don't think you could get it ABET accredited because there's too much swing in what it is. It could be basically a computer engineering degree if you decide to focus, if you decide when you're taking your courses, it's like, okay, I really like computer engineering, I can just focus on computer engineering. But then on the other hand, you could focus completely on mechanical engineering. Or we could have someone that takes a little bit of mechanical, chemical, electrical, mechanical. So I don't think you could get it accredited, and people don't like that. When people go to programs, they want their ABET accredited degree, even though it doesn't really mean anything. It's a minimum standard, but in reality, it's a minimum requirement. It doesn't say anything about the quality of the education. It's saying that it meets some minimum requirement that they have. There's a minimum math requirement. There's a minimum. I think there's minimum courses that computer engineers should have, what mechanical engineers should have, or what knowledge they should have by the time they graduate. That's the reason why this degree doesn't work. I've got a solution. Get rid of high school and replace it with an undergrad in math. Listen, before we do the hot take on the normal public education system, which I don't feel equipped enough to deal with, I'm going to focus on the optional collegiate education, and specifically the optional collegiate education in engineering. I don't know. Does anyone here have any thoughts on this? Does this just seem like a better idea for most people? I feel like because nobody knows what engineering really is when they get into it, and I say most people, there are some cases that do. I feel like because most people don't know what engineering is when they get into it, if they have the ability to kind of survey around, I feel like this is just a better idea. It just seems so much better. Now, this is all theoretical, so maybe it's awful. But I don't know. I've never told anyone this before. This is more or less my hot take on what I think it would be better. Do you think that 4 years is too short for the average person to develop an interest in a subject? No. I don't think 4 years is too short. I feel like, so if you're asking the opposite question of, if you're asking a different question as far as is 4 years an unreasonable amount of time for what most universities expect, the answer is yes. Do I think that colleges should be 4-year programs? No, they used to not be. Engineering degrees used to be 5 to 6 year degrees. They used to have more hour requirements, and they used to be longer degrees. But with rising costs of tuition, now there's this finish in 4 mentality. I don't think that it has anything to do with developing an interest in the subject. Wait, no, more that it's possible that you won't figure out exactly what you like because you have pressure to pick what you like in the first semester. So that's what that thing on your screen right there, that general studies and engineering degree, that's what that's supposed to fix. The problem is that people get into a major and then they don't want to face the penalty of switching majors and half their degree being useless. I think a good amount of the problem is that American universities require a lot of general requirements, and this mostly because of our high school primary education is pretty weak in general, so universities need to make sure that their students have fundamental knowledge of writing at the college level. And yeah, listen, I agree with you. I agree. I'm not going to dispute that. I mean, I almost died taking microeconomics and taking writing composition 1 and 2 and taking a world history class. I almost died taking those classes because they were so boring. They were jokes. I may have picked up 1 or 2 fun facts. Where you would have more time to sample in a more narrow scope if you applied directly to departments. Well, I mean, this goes back to this idea that I think it's probably a better idea to start this specialization in high school. I feel like high schools are too rigid. High schools, everyone takes the same stuff pretty much. I had 2 years of AP credits when I came in, so I had time to take whatever I want. See, I took the opposite approach when I started, but that was because I went to a university that didn't accept AP credits, and so I figured it was 2 things. They only accepted 5s for some things, and then the things that they didn't accept 5s for, it was like you might as well just take it here because you're paying for it anyway. So because I had to pay for the classes anyway, I might as well be taught by a university professor. And it was a small it was a small private university that I started at. And so because of that, I mean, I had really, really good teaching professors. So I'd rather have learned it there than the mediocre one I had at my giant public high school. But honestly, there probably should be more flexibility at the high school level. I'm not going to get into that because there's way too many problems with the U.S. public education system to think that giving students more choices would make things better at this point. There's too many problems, and I'm not equipped to say what solutions might work. So we'll talk about what solutions I think would work after that point. So I think you can do a good job doing I'm kind of skeptical. Well, here's the thing. I'm not talking about... So here's what I mean by early specialization. I mean early specialization as far as you give more freedom of selection. Not that they have to choose a set path. That they have more options to choose when they're in high school. So it's not as structured of a degree. they can start learning what they want to learn more and faster and start specializing in that earlier. Not that they have to become a computer scientist at the high school level or a mathematician at the high school level. I think that's a bad idea. My high school's idea of programming was MATLAB. I mean, it's fine if you want to do some linear algebra stuff, I guess. It's not good as far as computer science goes, just because it's so slow. But well, it's not good in a lot of cases, just because it's so slow. If you want to do anything in the real world, you're not using MATLAB. Or I should say, if you want to do something that's high performance in the real world, MATLAB's too slow. But you can speed MATLAB up. You can actually do you can use precompiled C libraries to optimize your MATLAB code. Okay. So any other thoughts on... That's fine for high school, I think. Yeah. I think for middle school, it still needs to be structured. Middle school's too early to start giving people choices. There's still too much foundational knowledge they need. Like, you need to get past algebra before you can start worrying about focusing on what you want to focus on. Everybody should know algebra. There's not a single person in the world that should not know algebra. Everyone should know algebra. So I think at the high school level, it needs to be a little more loose. You didn't figure out what you wanted to do until after college. Well, that's because of the way the system currently is. It doesn't allow any exploration. You're in a degree. The degree already costs a ton of money. And then if you figure out halfway through your degree, you run the risk of, well, do I want to spend an extra year paying money I don't have to get a degree that I'm still unsure of? If you want my hot take, we should severely reduce everything but math and language in elementary school and middle school. Maybe? Oh, wait. What do you mean by... Oh, wait. Never mind, I read that wrong. But math and language. Yeah, I'm with you there. I think that's a good idea. History is not great in most schools. It's just memorization. I mean, I kind of agree with that. Most of history stuff is memorizing dates. Well, at least in the schools that I went to. I went to public school. I didn't go to any fancy private schools. I went to normal, giant Texas public schools growing up. Not in rich areas either. In fairly lower income areas. Giant schools where the biggest thing at the school was high school football. I think history is super important and science is important. But I don't think you retain... Well, so here's the problem. The problem I think you have with history, though, is that it's just the way that it's taught. And same thing with science. Science is taught and history is taught without context. So you don't have to do any critical thinking on history or science when you're in high school or middle school or elementary school. You're just memorizing stuff. So it's fundamentally different than the science that you would learn in... or that you should learn in high school, or that you should learn at university. But I don't think you can give 10-year-olds the same context you can give an adult. No, you can't. But you can find a way. There is a way to give them a context that they would understand. A 10-year-old kid does have the ability to do some critical thinking. So, I think about the science, you're right. I think we can avoid a lot of this. Well, we can avoid a lot of the science because a lot of the science is everyone just memorizes that the mitochondria is the powerhouse of the cell, right? That's what most people get from biology, right? That's what I got from biology when I took it in middle school. but that critical thinking works in more abstract settings. Is sexual orientation determined at birth? I have no idea. I'm a computer architect. I have no idea. You're asking me a biology question or a psychology or biology question to a computer architect. I don't have an answer. Look at a research topic. Or look at a research paper. Maybe that has the answer. I don't have the answer. I can tell you how a reorder buffer works. What do you think about having elementary have specialized teachers like high school? I thought a lot of elementary teachers hated math, and it reflected on their teaching. We're getting into an area that I don't feel comfortable talking about, but there's a fundamental problem there. You said takes on engineering, education, and politics. I have a specific take on politics that I'm going to get to. I don't have hot takes on all politics. I was looking at my phone. So Lev, you're criticizing the problem there is with the teacher. It's not with the education system. If you have a teacher that's fundamentally disinterested in math, it's the problem with the teacher, not the problem that you don't have a specialized teacher for math. Teach them about the history of juice boxes. Let's see. I.e., you cannot teach 10-year-olds about world history when their primary interest is in juice boxes. So you're left with super sanitized history. Teach them, but children are very good at playing chess or other forms of abstract critical thinking. You had super bad math teachers. Yeah, a lot of people do, because a lot of people think that in high school, and I think Riemann Zeta will agree with this, is that a lot of high school and lower level math, they teach you math as memorization. They teach it, memorize how to do it this way, do it that way every time. I think Riemann Zeta would agree that that's how a lot of public education school math works, and a lot of elementary high school math works. They don't explain why anything happens, they just say memorize it and do it. Plug and chug. The two worst words the mathematician can probably hear. Plug and chug. Okay. Let me see if I can catch up. Sure, but I think you'd agree with me on the general. Right? I think you'd agree with me that generally. Okay. So I don't agree with getting rid of all history, and I don't agree with getting rid of all science necessarily, but I think that getting a better foundation of math early on is beneficial. Getting a better foundation of language is beneficial early on. And I don't know enough about the critical thinking capability of 10-year-olds, 8-year-olds to... Yeah, I mean, I agree with you here that the worst thing you can do is tell students to just memorize something. It's the worst thing you can do. Because then it's pointless information if it's just memorized. Memorized information is pointless. It's like if you memorize a table of melting points of elements or something, it's pointless unless you have the context of when you would need the melting points of elements, right? But just knowing it and writing it, being able to write it down is pointless. Or like pi, having pi memorized to 10,000 places. Okay, who cares? Who cares if you know pi to 10,000 places? No one does. Doesn't like pi to 27 places? This is just a fun fact. Isn't like pi to 27 places already give you like the precision of like a nanometer or something that's, I forgot how big it was, but like a circle that was of some size, it gives you the... I don't think training children's memories is bad, but it works a lot better in context, like vocab. Yeah. Well, I mean that. So this goes into a point that I can't talk about because I don't know the critical thinking capability of children. I know it can be pretty darn good in some circumstances. There's a lot of. It's like the one dude that said, "Okay, I'm going to do a." Who's the one guy that decided he was going to do a nature nurture experiment, and he had all his three kids learn how to become like chess prodigies, and they all ended up becoming grandmaster champions, including his like daughter became the greatest female chess player to ever live, and the other daughter became the second greatest chess player to ever live, or female chess player. Maybe that's his name. Yeah, Susan Polgar. Sure, maybe. Yeah, sounds right. Okay, so that's my hot take when it comes to education. Anyone have any other points? Yeah, I just looked it up on the other monitor. Yeah, he was like a what was he? Was he a yeah? And he was a teacher and educational psychologist. That's right. Yeah, it's a really interesting subject. The whole nature versus nurture thing. What does your not yet wife do? That's classified. Um, wasn't Boole a high school teacher? Maybe. I don't know. I don't know much about his personal history. Um, she's going into the Air Force. She's finishing her degree and then she's going into the Air Force. Um, Not enlisting, she's commissioning as an officer. I should clarify. But yeah, there have been zero history prodigies at like 13. Well, I mean, it's a fundamentally different thing, right? You don't go to a history competition, right? I mean, I don't know what you mean, but I don't know what you mean by history prodigies. The best memorizer of history facts. Um, it's a very different skill, right? Is she going to fly planes? She wants to. She wants to do combat search and rescue, but she wants to do helicopters, not planes. Um, okay. Nobody has published original historical work at 13. I mean, sure. Um, I agree, but to compare them doesn't make sense. They're so different of areas that the work you do just you just don't have the life experience to put history into context at 13. Sure, I mean I agree. I don't know why we're comparing these two. I guess you're trying to make the comparison that fundamentally, at such a young age, you're better suited for certain things. So it'd be better to learn the things you're better suited at earlier. And then once you have the ability to maybe comprehend the other subjects, start learning the other subjects. Is that your point? I think that's your point. Do the comparative advantage meme, where you're better suited to learning mathematical stuff and maybe language stuff at a young age. Because that critical thinking is better suited to math languages than what you don't have the background to understand. Okay, so that's the gist. Okay, I got you. I know what you mean. I don't disagree with you. I don't have enough data to back any of that up. But I feel like this is pretty. This is self-explanatory. My idea for a degree. Well, I mean, there is one there is one. Okay, summarize real quick. So the idea is, let's go up here. So, in an engineering degree, oftentimes you can take a lot of classes that have no relevance and that you don't care about. Now, there's generally two situations for someone going into a degree. They come in as a freshman and they know exactly what they want to do and they get that degree. In that case, these classes might be absolutely pointless. They don't care about them because they want to be a computer architect. So this is 9 credits minimum of rigorous technical work that they will never use again. The other thing is they might come in as a freshman. They want to swap concentrations because they take control systems and they want to be a control systems engineer. They take a mechanical engineering class and maybe they want to completely switch majors to mechanical engineering. And so the problem is that general studies, which is a degree where you basically can build your own degree plan, by most places is considered a joke. It's considered that's what you want to do if you don't want to spend a lot of effort and you just want to get a degree. It's considered a joke, and I don't like that. I don't like that it is, because it seems like that's the most academic degree that exists, is a general studies degree that embodies what academia is supposed to be about more than anything. So I think that a general studies and engineering degree has potential, and it has potential because you're allowed to survey different engineering degrees, and there's no penalty for taking this broad coursework, but it also allows you to specialize. So you can only take classes, you can choose to only take classes in computer engineering, and you will have, as good of a computer engineering degree as someone that's a computer engineer. Or you can have as good of a mechanical engineering degree as a mechanical engineer. But if you have a job that requires this subset of skills from mechanical engineering, this subset of skills from electrical engineering, you can take both and still get a degree. And the only con that I saw with this was ABET, was that I don't know if you could ever get a degree like this accredited. ABET is an accreditation organization primarily for the United States for engineering degrees. And they're basically the people that says, this is a quality engineering degree. It meets our requirements to be considered a quality engineering degree. And I don't think you could have something with this wide a variance of specialty get passed by ABET. So that's my idea. Makes sense? I think it makes sense. I think it's a good idea. Does anyone have a better idea? That's a better question. Does anyone have a better idea than this? How do you make a degree that better suits something like this? And the biggest problem here that we're facing, if engineering degrees didn't cost, or if degrees didn't cost so much, then I would ask you if you wanted to use some drawing software that made your writing less messy when you use a mouse, but it's Windows only. Yeah, I know. Listen, there's a lot of problems. I'm still getting used to writing on a Wacom tablet and looking at the screen while I'm writing. And then secondly, listen, I used a VM of Windows 10, and I used what's the software? OneNote on there with this tablet, and my writing was absolutely fine. And then I switch over and I use any of the drawing apps on Ubuntu or these Linux ones. There's something different about it that makes my writing look atrocious. I generally consider myself to be a pretty decent writer, or pretty decent handwriting, but it doesn't translate well. I agree. Okay, so that's my hot takes on an engineering degree, and it doesn't look like anyone has any other ideas, so we can move on to the final hot take of the day. Why not just say that as a PhD, your handwriting is messy? I don't have a PhD yet. I'll say that after I get my PhD. then I can make then I can say it's because I have a PhD. I'm allowed to have messy handwriting. Okay. Did I do a new page before? Oh yeah. So let's do new page after. Okay. I think you could try new Krita 4, but that's unrelated to the stream. Maybe for off stream you can try. Okay, I'll look it up. I feel like I saw this before. This one just seemed like digital painting, creative freedom. Okay. Oh, okay. So it's a drawing. It's more for drawing. Yeah, I got this one just because it was so easy because I can do file, annotate PDF, and it allows you to import a PDF so easily. That's why I chose this one. But yeah, I'll check that out. So let's move to the last thing. And it's my hot take on the only political hot take that I generally have, right? All right, so let's go to the political hot take. Listen, I'm not going to say anything about I don't agree with most of Trump's policy, but that's not my hot take because most people don't agree with, or I say most people, a lot of people don't agree with a lot of Trump's positions, and that's becoming increasingly apparent with the tariff stuff. Most people don't like trade wars. I feel like most people don't like trade wars. Politics on Twitch, yikes. Yeah, but this is interesting politics. This isn't like yell at somebody politics. This is like theorizing a new way that a bill becomes a law politics. This is more interesting to me. Okay. So this is where my inner out of touch academic comes out. Right? This is where my inner out of touch academic comes out. So let's talk about how does a paper get accepted to a conference? Option selects. Accept the people who are benefiting from the trade war by implicit redistribution. Yeah. Might be getting something on the nose there, right? Only CE PhDs should pick the president. Listen, I could argue for the technocrat revolution, but that's not going to get us anywhere, is it? No one's going to go for that. They tried that under Eisenhower, didn't they? Okay. So here's the first question. How does a paper get accepted to a conference in an academic setting? You like this topic, right? Me too. So at least in computer engineering, this is how it goes. So 1, you write a paper. 2, it is a blind submission, meaning that there's no authors attached to the paper, and you're supposed to remove anything that might hint to what institution that it's affiliated with. Like instead of saying we use our proprietary NVIDIA architecture simulator, you say we use an in-house simulator, right? So there's no authors, and then there's no reviewer information. You don't know who it's getting reviewed by. And you're also supposed to conflict yourself out. And then we'll put this as a little sub note as A, which is conflict out. You have to mark your conflicts. So people that you worked with, people that might have been your advisor, people that you've co-authored with, anything like that, they're not allowed to review your paper. So there's a blind submission, meaning you don't know who the authors are and you don't know who the reviewers are. So then 3, reviewers who specialize in your topic review the paper. So if you submit a paper on GPU microarchitecture, it's going to be reviewed by people that specialize in GPUs. It's not going to be reviewed by people that are only operating system people. That'd be very unlikely, unless you have some operating system GPU crossover thing. But if you do something that's specifically GPU microarchitecture people, it's going to be reviewed by people that do work in that area. Maybe it's industry people that are on the PC committee. Maybe it's academic people that are in the that are on the PC committee. So the third step is that reviewers who specialize in your topic review the paper. 4, rebuttal. So here you get feedback, and you have room to make, it's generally limited word count, and you can respond to reviewers. So any questions that they have on your paper, anything that they disagree with, you have the ability during rebuttal to write your clarifications, explain further, and address the concerns that they have. So then, after the rebuttal, there's the PC meeting. And this is going to be a multi-step thing. So if a paper was given very high review scores, so like all 5s, so we'll write this in here, high scoring papers, they get sent to the next round. B, low scoring papers, they get kicked. They do not get considered even further. And sometimes this will happen up here. You won't even get to rebut a paper if the reviewers don't like it. They will just say, you're out before the first round reviews, you don't get a rebuttal. So is this your hot take, or is this current state of affairs? We'll see. So this is still academia. You might have an idea of what my plan is for the political system, but this is just how academia works. So high score, and so let's talk about the more important thing. Let's talk about average. So what happens with the average paper? The paper that scores maybe some weak accepts, maybe some weak rejects, maybe 1 accept, maybe 1 reject. Usually not a reject. Maybe a couple weak rejects, maybe a couple weak accept. So it's kind of in the middle. So what happens here? So here, you get 1 person champions the paper. One person tries to get it kicked from the conference. So basically what happens is the person that basically scored you the highest on the paper, they will be the person that has to defend why your paper should be accepted to the conference. Then the person that disliked your paper the most, they have to get up in front of the whole PC committee and they have to say, this is why the paper should not be in this conference. So then after this, there's a vote. And your paper gets voted on, basically how well those 2 people convinced the rest of the PC committee. They decide whether your paper should move forward or not. And then D, or let's go to D, and then we basically get accept or reject. Or maybe they'll just say, hey, you got in, but as a poster. Which can be more annoying than reject, because that means, do I want to go all the way over there to present a poster? Yeah, so it's a little disheartening. But so this is the way that it generally works. Now, we don't have to get into, like, so the sixth step is out here, but it's not really relevant. And this is camera ready. So this is when you actually have to basically rewrite your entire paper to make it, grammatically correct, to make it sound like a real paper. So you nerds do posters. We try not to do posters. We don't want to do posters. Listen, poster equals wall of shame? Not really. Some conferences make you. Option select. So do you want to know something funny? So I think Micro, one of the top computer architecture conferences, they make you do a lightning talk, they make you do a poster, and they make you give a presentation. Sounds great, right? Okay, so this is basically how a conference acceptance works. And I'm pretty sure a journal is about the same. Journals sometimes have rolling deadlines, though. So conferences will be like one a year. Sounds exhausting. I don't get it. It's dumb. I shouldn't say it's dumb. I don't think it's useful. Okay, so this is basically how a paper gets accepted to a conference. So let's talk about how a bill should become a law. Interesting subject. I wonder if any of you could have thought about where this topic was heading. Lev, they didn't create jobs. The same people just have to do 3x the amount of work. There is no extra jobs created by this. It just makes poor academics like me have to do 3 times as much work. Okay. Overtime. Yeah, overtime on salary. I get a stipend. I don't get paid if I work extra. Okay, so let's talk about how a bill should become a law. So, I argue the process should be the same. There's my hot take. Let's see why. So 1, you write a bill, sure. Probably the same in both regards. The new thing, blind submission. You don't know who the authors are, you don't know who the reviewers are. Why is this a better system? I think this is a better system because it removes some of the pressure of introducing something that would be frowned upon by your constituents. So you're able to do things that are best for the country, just like, technically the Supreme Court is supposed to work this way because they have lifetime appointments. But you have freedom from worrying about elections. So the second part is the conflict part. So I don't know, implementing this, I don't know how you would do it. But this is all theoretical, so it doesn't matter. I can be as starry-eyed as I want. So the second part is that you conflict out, and I don't know how this would work, but you get to you conflict out people. So you no longer have, you get people that would be biased towards you. They don't get to consider this bill. In economics, because you know who is working on what, we have named submissions. I think bills would be the same. It's the same thing in computer engineering, though, option selects. You know who works on branch prediction because their past 10 papers were on branch prediction, right? You can you can do a pretty safe guess on who did what paper just based upon their previous work. Now, I'm not saying it's a perfect system, but it probably helps some. I would It would also feel bad if you voted for Mr. the bill who remove all barriers to abortion and you find out a year later through a leak, but it might be nice. Yeah, listen, there's a lot of problems here, but there's other things that would need to change as well for this to work. So and it's a lot of things that people are inherently against in the US for some reason. Okay, so let's go through a little bit more. So let's go. Okay. So then we have reviewers that specialize in their topics. This is where it gets a little bit different. So I find it really stupid that the people that decide on bills becoming laws generally aren't people that are specialists in economics or specialists in foreign policy. Now, it's really hard to not push for a technocrat utopia here where you have economists making economic decisions and you have foreign policy experts making foreign policy decisions. It's really hard to theorize that in a practical way, but there's probably some way where you can make this better, where you have the people that are the experts in economics or the people that are most qualified for foreign policy be the people that do this first judgment on whether something should become a law or not. Then I don't know exactly what the rebuttal would even be like, but then this leads to like what the PC analogous PC meeting would be, and that's where you have bills that the experts all said this is a good idea, this should go through. And then you have the low-scoring people said, like, everyone thought that this was a bad idea, so it gets kicked. And then the average paper, you have to have two experts fight it out about which should make it in. And then there's a vote by everyone, but it's only based upon those two people's arguments. Now, and then you get the accept, reject, or then the people whose bills didn't become a law, you make them make a poster. Chuckles, thanks for following. I appreciate it. So you make the people that that they didn't get in, maybe they do a poster of their bill. So this is a hot take on how I think it should be different. Now let's talk about the practicality concerns. Let me go through a couple things. So, Riemann Zeta, I don't think the problem with modern democracies is politicians being beholden to their constituencies, but rather special interests. I agree. If the state of information is the same, what is the advantage? Well, it's not exactly the same, because sometimes people work on stuff in different areas, so you don't know exactly who it's coming from. The bills are written by experts. They just sit in partisan think tanks. Yeah, that's a problem too. Economics is always evolving. Elections have a moderating effect on how fast and how radical we make economic changes. Economics is always evolving. Elections have a moderating effect on how fast and radical we make economic changes. Is that true? It's an interesting point. So I could see the argument for it, but I could also see an argument against it. And that's that, take the current presidency, right? So in the blink of an eye, someone could just say tariffs now, right? So that has nothing to do with elections, but that has a pretty significant economic impact. So I don't know if that's a fair statement to make. I'm not an economist or a political scientist. Just with special words like it's for defense. Yeah. Sure. So there are points on both sides of that argument, but I feel like you could find a bunch of examples where that's not true, that it's pointless to even say that it's a... If you can find so many counterexamples to it and you have to make so many exceptions to the rule, why is it a rule? Okay. So let's talk about what are the problems with doing this. So one, politicians aren't experts. Two, they represent constituents, ideally. So the fundamental problem with these technocratic implementations is that they have a bad history. Like, I don't think the privatization of the post-Soviet Russia was better off for being implemented by Jeffries. I don't know anything about that. But I feel like this is a better system, ideally. But ideally doesn't matter, right? I mean, our system doesn't make sense, and it doesn't work either. There's a reason why we haven't passed actual climate change legislation. And it's not because climate change legislation is something that's hotly debated. It's just because our system doesn't allow it to come through. So the fundamental... Okay, so I would like to see blind bills announced, if only to attempt to avoid the partisan stuff. The shock capitalism doctrine given to post-USR was disastrous. Well, I mean, this is like a completely different argument. We're talking about radically changing an entire economic system rather than... I mean, I guess we're talking about radically changing how bills become laws, but I don't know if these are even comparable. Okay. So, what's another problem here? So, another problem is an economic liberalization and a slower political one, similar to China, would have been far... I can't get into this conversation because I know nothing about it. Okay. So, they represent constituents. What else is there? What other problems are there? But the representation of constituencies is disconnected from authoring bills. You represent a constituency by voting along their interests. I don't understand your point. Isn't the... Now, campaign promises are different, of course, than what happens in reality, but I thought the whole point of campaign promises were you're going to represent your interests and you're going to vote along their interests. And when you introduce a bill, you don't introduce a bill that goes ideally. Now, it happens all the time where they do, but you introduce a bill that is supposed to be for your interests of your constituents. You generally don't introduce a bill that is against the interests of your constituents. Am I wrong? I don't get what you're saying, why they're disconnected from authoring bills. That seems just wrong to me. Now, in a practical sense, can they be? Unless your constituents are, and they don't know what is in their interest, well, that's all constituents, right? Or most constituents. Most constituents don't... Democracy isn't the best thing anyway. I agree. I wouldn't go so far as to say democracy was a mistake, but I mean, there's pretty clear implement. If you look at any other, uh, if you look at any other, not political system, if you look at any other field, and you look at how research works in those fields, it doesn't work based upon, let's see, sure, but an idealized scenario, representatives just aggregate the will of their constituency on the issues that are presented. Yeah, I know. So that's part. So option selects. You see the problems thing right here. I get that. So the problem is that they represent constituents, and they don't represent the United States. Does the solution remove the ability to revise a bill in the House and Senate? Well, I mean, that's ideally what this... Well, so this fundament... So, okay, so what's the problem number 3? This requires fundamental changes of who represents what. I would argue that this is tough because I would argue that it would be better if the people that elected represent the United States and they don't represent the individual states. Because we're talking about passing laws that have effects on every state, but people are voting in their own self-interest. So that doesn't make sense. Now, this is one of those things where it gets really tricky. Well, I mean, this is a different problem. Best interest in your eyes is different than best interest in their eyes. Like, you ultimately cannot reduce politics to technocratic implementations because classes of people have different philosophical principles. I know, so this is all part of the problem, right? So there's certain things that make sense, though, right? Under this idea, there's certain things that make sense. Like, if you think about what's best for the United States versus what's best for a single state, or maybe not even a single state, what's best for the people that a constituent gets all their money from, you know, it's a lot, it's really different. And so, I mean, politics is difficult. I'm not a political scientist, and I'm certainly not. That's why this is a hot take. So you're talking about centralization with more future-minded policy instead of short-term political grandstanding in elections. Listen, I think that if we optimized what's best for the United States versus what's best for an individual state from an individual person that has individual interest groups that support them, I think we would probably do a better job. And I think that if it was a more blind review process, if there was some way to have objective experts, which is pretty hard, then, you know, praise General Secretary Xi Jinping. Yeah, it's tough, but this is a hot take. I think our system is bad. I think our system allows, but then I would argue that our election system is also pretty bad. Like, just by the fact that there hasn't been any climate change legislation pushed through. I mean, how is that defensible in any circumstance? How is it defensible? It's not. You can't defend it. You can't say, oh, we'll get around to it. It's like one of the most pressing issues. The problem is, would voting records still be public? Sure, why not? Maybe, or I don't know, maybe not. No, let's say they're not. Maybe it's exactly like a paper. You don't know who voted on your paper to get it accepted. I mean, what's the benefit of knowing? The benefit of knowing who voted for your paper is only if you're talking about this super partisan system where you represent constituents and not the United States. If no, we kind of remove the accountability aspect of the system of checks and balances from the constituency. Yeah, but then you get into the argument of, does the constituency, do their opinions matter? Like, if everyone's calling for something that's objectively bad, is that something that should still be respected? And that's an interesting question. You don't need objective experts, but experts with different views able to collectively pick the best options? Sure, I agree with that. As long as you have enough of a pool of experts, then there should at least be some consensus of what's a good idea. Political tribalism in the digital age will be the end of this country. I'll see you at the end of the Second American Civil War at the Congress established by the People's Republic of America. Kinda. It is a democracy. It's supposed to be led by the people to some aspect, I guess. I don't know. It's hard to say this when climate change can be brought up. Yeah, I mean, it's not just climate change, right? It's 1,000 different things. It's climate change. It's social reforms. It's even economic stuff. Who would vote for tariffs? Tariffs have never been a good idea. Like, the only way tariffs are a good idea is if you're trying to, like, impose sanctions, right? Or you're trying to, like, penalize a country for doing something bad. Like, work it out. I don't think anyone agrees that tariffs are a good idea either. What else? What else is a big meme thing? Education. Education. We do nothing for education. We do nothing. We say leave it up to the states, and then what? West Virginia had a teacher walkout that lasted how many weeks, or days? What? Why? This is awful. So the system doesn't work. That's the problem. Education is it's so bad, and it's indefensible. Like, who's going to defend it? The people that are in the good areas that have good schools, they get to defend it. But as long as there's still walkouts where schools are out for weeks because teachers just are on strike, how do you reconcile that and think that the political system is good? I don't think you can. That's okay. So that's my only political hot take. I don't know enough about politics, and I don't care enough about politics, honestly. Occasionally, I come up with another hot take after I read something, but note that none of these political opinions could be. I don't know enough. I haven't read enough Actually, I won't even say that. It's not my job. Right? I'm not a political scientist. There's probably political science theory that says what probably would be better. Looking at tuition rates of schools outside of California is insane. So here's an interesting fact, Lev. In 10 years, the cost of tuition in Texas schools has risen over 200%. In less than 10 years, in like 8 years, actually, since 2010. It's risen like 200%. What happened was that there was a deficit in the budget, and what the Texas what the Texas government said was, we're going to cut some funding from universities. And so because we're doing this, we're going to uncap tuition and we're going to uncap fees. So want to know what the schools said? Okay, that's a blank check for us to increase tuition and fees however much we want to raise as much money as we want. What is yearly tuition? Most of UCs have risen a ton, but they are still vastly less than most state colleges outside of California. I don't know. It differs from school to school. It depends on the school. My technical tuition is like 36,000 or something a year, but I get a tuition waiver, so I pay $0 in tuition. But that's just because I'm a PhD student. PhD students generally get tuition waivers. It all depends on the school, though. And you're probably right, Lev. California probably is worse. I think my undergrad. I don't even remember my undergrad, man. The school that I went to, that I started at my undergrad, was $52,000 a year, Lev. It was 52 grand a year. For tuition only, it's 10K in-state and 36K out-of-state. Is that tuition or tuition and fees? Tuition and fees? Sure. I gotcha. 10K seems low. I feel like it's 10K seems really low. I feel like that probably. I mean, I'm not questioning that you looked up the wrong number. I'm sure you looked up the right number. It still seems low. I feel like that's not accounting for something. I don't know. Maybe it's not. It's probably not accounting for all the extraneous stuff. Maybe, I don't know. Not California is way less tuition than the what? Are you trying to say outside of California tuition costs less, Lev? I'm guessing that's what you're saying, and I mean I don't disagree. Probably, the most expensive school in the U.S. is Harvey Mudd, right? Harvey Mudd's the most expensive school in the U.S., right? I feel like I remember seeing that someplace. Probably, or some other private institution. Sorry, I was talking about UC, CSU system. You can't compare private to public. Yeah, of course not. Guardian. Oh, okay. Yeah, you can't compare private to public, but you have to, right? They're schools. They're schools that you have the choice of going to, so you have to. I mean, that's like saying I mean, you have to compare them. Purdue and MIT and UT and Stanford are all competing against one another. So you can't just say you can't compare private to public. I mean, if we were to say it that way, I mean, some know nothing school that's super cheap. I mean, all of a sudden that seems like a great deal. So you have to compare it to some extent because you're talking about you want a quality degree. Now, yeah, UC System School, public school is probably more expensive than any other state. I agree, and I think that's the point you're trying to make. Okay, what else do we want to talk about today? Is there anything else we want to talk about? That was my 3 hot takes, really. Listen, no, the opposite. Okay. Listen, if you guys want to give me your Twitch Prime subs, if you're not going to use them on Destiny, you're more than welcome to. Then maybe I'll be able to cash out at some point. Oh, UC is pretty affordable compared to other states. Oh, I didn't know that. Okay. Did you know that I need to make at least $100 before I can cash out any of the money that I've made? Is that weird? I feel like that's weird. Maybe that's why people like try to get donations so much. It's because Twitch requires you make at least $100, and then Donations you just get immediately through PayPal. Not to mention, if it requires you to make at least $100, and then they don't cash you out until 45 days after the end of the month. That's because Twitch takes a cut. I mean, PayPal takes a cut. So, I mean, what's the comparison? Why no love for Rutgers? I mean, did you want me to name every single school? I named the schools that were at the top of my head. 50% versus 3 to 5%. I got donated $3, and it got $2.50 taken out. So what is that? Or no, sorry, $3, 50 cents got taken out. About. So that's over 10%. That's like what, 20%, or a little less than 20%. Wait, 10. No, 330. No, it was like 15% ish. Or maybe it was 267. Maybe it is 10%. Yeah, I mean, who cares? Who cares what the percentage is? It's a percentage. The question is, why do they? The question is, why did they take? Why do you have to have a minimum of $100 and then they cash you out 45 days after the end of the month when you made $100? That seems. And then they take like a 60%, or not a 60%, a 60-cent transfer charge. I don't know. That seems really weird to me. I mean, having things go through PayPal just seems better. Yeah. Okay. Anything else? Do we want to talk about anything else today? Do you guys want any other hot takes? If not, I'm going to probably walk home pretty soon. We can talk about something else, though. Did you give up on learning German/Japanese? I gave up learning Japanese, but I'm waiting for what's his name? Is it Gershung from DGG? He's gonna actually join me on stream in about 2 weeks, and he's gonna help me learn German. So I figured I'd just wait till then. That way I don't develop any bad habits. Should school be allowed to be privatized? I don't know enough. Let's see. Should schools be allowed to be privatized? I don't know if my opinion has any validity. My opinion right now is yes, but it's based on nothing. But I don't know what you mean by privatized. I mean, the idea that people can pay for better education, it depends on how capitalist you are. If you think that more money, you should be able to do better things, and sure, if you believe in providing equal education, then the answer is no. I mean, I would guess I would lean more towards no. If you're talking about public education or something, or at the like K through 12 level, I mean, the answer no probably makes sense, because then it incentivizes people with more money to fund public education to make it better, and then everybody gets a better education. And I think that's probably the best outcome. Best type of coffee. In what sense? Like light roast, dark roast, or in terms of espresso versus a latte versus a cup of coffee versus an iced coffee, or what? Listen, I'm not a coffee snob, or I do like good coffee. I won't say I'm not a coffee snob. I think everything. Best type of coffee. I personally, it depends on the time of year. In the winter, I'm a big fan of a really good latte. In the summer, I'm a big fan of, there's something called nitro cold brew. Have you guys ever heard of nitro cold brew? Let me let you in on the greatest thing known to man. This is nitro cold brew. Nitro cold brew is it's infused with nitrogen, kind of like Guinness. And so basically it has the smoothness and the creaminess of, I guess, kind of like Guinness. I've never had Guinness, honestly. But it has this smoothness and creaminess, and it has this natural sweetness. And it's so good. This is the best cold coffee beverage in existence. You like iced coffee in the winter? I like iced coffee all the time, honestly. But when it talks, there's something about a nice hot latte from this place that I like to go, where when Zlatan, Zlatan Best or whatever his full name is, when he donated me the $3, I immediately went and I got an iced latte from one of my favorite places because they do really good espresso. And so it was hot outside, so I got an iced latte. But yeah, this is the best beverage. If you want a cold coffee beverage, skip the normal iced coffee. What method is best for making coffee? French press is pretty good. I don't have anything inherently against drip, but French press generally turns out pretty good. There's tons of people that think that are all about pour overs, but I mean, I guess could be fine. But yeah, nitro cold brew, it's honestly the best coffee I think in existence for like a hot day. New Starbucks cold foam cascara. Here's a fun fact. I used to work at a Starbucks. Have you seen the Japanese iced coffee technique? Maybe. I see. Is it just a pour over? Is it just a pour over into ice? What am I supposed to be looking for? Yeah? Oh, okay. So it's like any other iced coffee. I thought it was something special. It's just iced coffee. I mean, it's just a pour over. It depends on how much you're staking in the pour over. I mean, the way that they make the way that every place makes iced coffee is that it's less acidic. Doesn't the acidity come from the coffee, not the brewing process? Maybe I'm wrong. Yeah, that's what I just said. It has to do with the beans, not the way it's brewed. I mean, I've had plenty of brewed coffee that isn't acidic. Get yourself one of these. AeroPress. Ah, okay. This looks like a pretty good meme. Claim to have roughly the same concentration of it as espresso, higher pH, thus lower acidity than drip coffee. There's probably some effect. I was told that cold brew coffee is less acidic, but I never checked. Maybe. I don't know enough about... I worked at a Starbucks, so that means I know nothing about coffee. No, I know coffee somewhat. I want to try V60. What's V60? You want to try a Volvo? Why do you want to try a Volvo? Tokamaka, why do you want to try a Volvo? This is what Tokamaka wants to try, by the way. He wants to try a V60. Dumping it straight into the ice is supposed to limit the oxidation or something. Yeah, maybe. But I mean, that's what all iced coffee. I mean, that's basically how we. Oh, it's Japanese thing for making coffee. Okay. Um. Yeah, I might. I mean, he wants to try a V60 in his coffee. Let's see. Let's look up V60. Oh, it's his first article. V60 coffee. Oh, it's the exact same that we were just looking at, right? It's just a pour over thing. Okay. It's just a pour over thing. It's exactly what we were looking at when we looked up Japanese iced coffee. Makes sense. Okay. Have you ever tried a percolator? Those are kind of memey. Yeah, at some point. I think I have. Yeah. I don't own one, but I've used one before. Listen, do you guys honestly want to know, Lev? Do you want to know what my favorite drink is, honestly, or everyone? Do you want to know what my favorite drink is? This is my favorite drink. It's a doppio campana. It's a shot of espresso, and then you put a little bit of whipped cream on top. This is my favorite espresso drink. Or this is my favorite coffee drink, period. Because I have an espresso machine at home, and then I make my own whipped cream, and it's absolutely fantastic. Because you get still the strong bitterness of the you get the strong bitterness of and have you guys never heard of a doppio campana before? Espresso campana? You guys obviously aren't Italian aficionados. It depends. You got to think about the layers of the espresso. You have the crema, which is the very top, which is sweet. Then you have like the body, which is a lot richer, and then you have whatever the third part is, right? Let's see. Parts of an espresso shot. Yeah, you have the crema, which is the top part, which is the super. It's really kind of sweet, and then you have the body, which is a little bit richer and has that coffee flavor, and then you have the heart, which is the very bottom of the espresso shot. Which is where a lot of the bitterness lies. And so your ideal espresso shot, if your espresso shot has been pulled correctly, it should have these pretty rigid separations. My works machine department was all Italians. I could steal their espresso. Yeah, it's great. See, you want this. If you pull an espresso shot correctly, it should have this separation, and it's beautiful. A espresso shot just by itself, like this, if done correctly, is absolutely amazing. Which is the reason why Starbucks is so bad. It's just so bitter and awful, and it's a single note. So yeah, don't go to Starbucks and just get espresso. Never order. If you go to Starbucks and you order espresso, you stop right now. Don't do it. Don't do it. Reconsider your actions. It's not good. It's like going to Starbucks and ordering something like Pike's Place. Pike's Place is one of the worst coffees I've ever had. Bar none. It's so bad. Okay. Do we have anything else today? What else do we have today? What do we have going on? What is everyone doing with their weekend? Is everyone having a wonderful weekend? What are we doing this weekend? I'm sure some of you probably watched the World Cup. The team that's supposed to win finally won, which was England. What happened with the Russia game? World Cup results. Click. Croatia beat Russia. I don't know if that's supposed to be an upset or not. You know the history of the espresso. Machine. It was an invention of necessity of a landowner, large farm, who wanted his laborers out of the field quickly, so invented a machine to give them their coffee more quickly. Oh, I didn't know that actually. That's pretty cool. Croatia was supposed to win. It's amazing it took to penalty kicks, though. Yeah, I mean, I assumed. I didn't assume. I mean, I assumed Russia was going to lose to Spain, though. So, I guess anything can happen. Okay. Let me go over here. Let's go to the full cam. Okay, guys. Thanks for joining me today. And if you guys don't have any other topics of discussion, we'll probably close it out here today. Straight from the architecture lab. I thought the meme was that they were easily one of the worst teams coming to the World Cup and had lost like 6 straight. Maybe. I don't know. Anyone have any last talking points? Anything they want to bring up? Nice shirt, buddy. Hey, thanks. I debated between wearing my watermelon shirt today, which is dark blue with watermelons on it, and my cactus shirt. And so I decided to wear the cactus shirt today. Weekends are my casual days. The rest of the days of the week, I generally wear like slacks and button downs because I'm generally in meetings with people that I generally want to look good for. So weekends I can play it a little more casual, shorts and a button down like this. Okay. Anything else? Anyone have anything else? If not, I want to thank you guys for joining the stream today. We had a lot of fun here today. If you guys want to follow me on YouTube, I'll be available on YouTube. If you guys want to follow me on Twitter, I have a Twitter now. So that's fun. It's all linked below. If you guys want to tell the guy behind you that he needs to clean his desk of excessive cords, listen, I don't have any authority with him. He works under a different professor. If you guys ever want to buy me a cup of coffee, you're more than welcome to. You're never obligated to. If you guys want to throw a Twitch subscription to my a Twitch Prime subscription my way, you're more than welcome to as well. But in any event, I'm glad you guys were all here. I think we had a good discussion today about some of my hot takes. Maybe we'll do some of these every once in a while. Thanks for the stream. No, thank you for joining me. I appreciate it. If you guys ever want to message me with any questions or you want some dedicated content for you that you want to learn, just send me a message on some platform. I'm happy to respond. I don't have that many people messaging me yet, so if you want to get in on the ground floor, now's the time. I'm debating what to do with the stream. I think that the way that I have it set up now is bad because I think that most people don't want me to go through books. I like going through books because I have the naive academic sense that people will get a holistic education, but I think people just don't care and they want to pop in and out. So I think it's better if I maybe just do problem solving on stream. And so we'd probably switch to doing more problem solving on stream. That might be the better idea. But in any case, hey, thanks for joining me today. As always, I hope you go out there and you learn something new. I'm Nick from Engineering Today. Thanks for joining me.